In this last video, our focus will be congruent triangles or polygons. Congruent triangles are when all parts of the first shape are congruent to all parts of the second shape. And we're going to practice identifying all those congruent parts as well as writing congruent statements. In this example, I've got two rectangles here, and I've labeled them with angle markings as well as some side measures, and then of course each of the vertices. And what we're going to do is practice identifying the corresponding angles and the corresponding sides, because if each angle has a matching angle and if each side has a matching side, then we can write a congruent statement that says the two shapes are congruent to each other. Let's start with the angles first. If I'm going to identify corresponding angles, the first thing to look for would be angle markings. That's going to be a way to identify things that go together. So if I want to say angle A is congruent to something, I'd look for the other angle that has the same arc marking, and that would be angle J. So angle A is congruent to angle J. And then I could also say the same about angle C and H because they have the same markings. So angle C is congruent to angle H. The other two don't have markings, but based on the direction that these are going, if you think about them facing the same way, A and C are along the same side, so that means B and D and M and L would have to go together. So angle B would have to be going with angle M since it's next to angle J and A. So we'd say angle B is congruent to angle M. And then lastly, angle D and L would have to be corresponding. So I'd say angle D is congruent to angle L. We can do the same thing with the sides. If we look at the side lengths, we can match those up. We could start with angle or side AB. It's a length of 2. So its corresponding side would have to be side JM. Notice that as I write my sides, I'm going in the same order. A came first, so J has to come first because they were corresponding, and so forth. So now let's look at the longer side from A to C. So side AC would have to be congruent to side JH. And then the other two we don't have marked, but we can go ahead and talk about them. Let's do the short side first. We can say that segment LH would have to be congruent to this side down here. And remember, I have to go in the same order. So if I started with L, that means I have to start with D. So I'd say segment DC. And then lastly, we could say that side ML would be congruent to side BD. As long as you have the letters written in the correct order, then you should be good to go. So now, because every angle has a corresponding angle and every side is corresponding with another, we know that these two shapes would be congruent, and that means we can write our congruent statement. When we write our congruent statement, we name the entire shape in any order you choose, but whatever order you choose, you have to match the same order with the other shape. So for me, I'm going to go ahead and write that rectangle, let's say, ACDB, so I went ACDB, is going to be congruent to rectangle. I have to start in the same order. If I started with A, I start with J. So J, I went to C next, so I go to H next, and then L and M. So when you write these, order is very, very important. Make sure you write that in your notes. I will be looking to make sure that the letters are in the correct order, and if you want to check, you could match each letter. A goes with J, C goes with H, D goes with L, and B goes with M, just like we listed it with the angles. So this is a good congruent statement, and we'd be good to move on. So we're going to use this concept of congruent polygons or triangles to help us solve for missing angle measures, missing side lengths, and then also when we later do some more proofs. Let's look at our first example using congruent triangles. So here it says in the diagram, we have triangle, I forgot to mark that in there. Triangle ABC is congruent to triangle DFE, and they want you to find the missing values of X and Y. Now, before we actually start solving this, there's this big piece here that we want to make sure we write in our notes, CPCTC, and what this stands for is corresponding parts, so that's corresponding parts of congruent triangles are congruent. So each letter has its own, or each word has its own letter. And this is really helpful because if I tell you two triangles are congruent, that then any corresponding parts have to also be congruent. So this allows you to set up equations without having to prove why they're the same if they're not marked. So just by saying the two triangles are congruent, now we can match things up. That's what CPCTC does. So make sure you know what that means. That'll come in handy later. And so if I want to solve for x, let's say we want to solve for y. Here's an equation that just has y in it. So angle F, we know, is going to have to match up with angle B because they're in the same location in our congruent statement. So that means that this equation here would have to be using these two things. So I'd say 8y minus 5 has to equal 99. So then we could go ahead and solve. If we add 5 over, we get 8y equals 104. And then we could divide by 8. So if we divide both sides by 8, we get 104 divided by 8. 8 goes into 10 once, and 8 goes into 24 3 times. So we get that y is 13. And there's our first solution. The second equation would involve the one that has x in it. So because we know that FE is on this side, so FE is the last two letters, that means it has to go with BC. So this is a good way to identify the parts that go together. So we'd have 2y plus x has to equal 38.4. And then we know what y is, so 2 times 13 plus x equals 38.4. And then we can multiply that out. We can get 26 plus x equals 38.4. And then subtract that 26 over. And we get that x is equal to, 12.4. And we're done. Okay, so it's all about matching up the different parts of the shapes based on the congruent statement. Make sure you know what CPCTC stands for. And the last theorem that you want to know for this section is the third angles theorem. And this is really helpful if you don't have everything given to you. So here it says if you have two angles of a triangle that are congruent to two angles of a second triangle, then that automatically means that the third angles of the triangles have to be the same. So here they've marked that C and K are equal measures, and B and J are equal measures. And since we know we have two pairs, then what this says is angle A would have to be congruent to angle L. In the last example, I want you guys to try this two-column proof. I've laid it out for you already, so you just have to fill in the blanks. You're trying to prove that the two triangles in the diagram are congruent based on the given information. So there are 4 things given to you, and this is a 5-step proof. I've gone ahead and laid it out for you. I want you guys to use previous knowledge as well as some of the new things we've learned in this section to try to fill in the blanks, and then I will check that in class.